Good morning, good afternoon, and good evening, depending upon where you are. Thank you very much for attending this screencast. I am Jinesh Varia, Technology Evangelist at Amazon Web Services. As most of you might already know, Amazon Web Services offers highly reliable, highly scalable, cost-effective cloud computing services. In this presentation, I'm going to tell you a beautiful love story. The story will tell us how you can start small and then grow gradually to build a powerful web application using all the different services that AWS offers today. So before I tell you that story, let me give you a brief overview of what AWS offers today and then go into it. So starting from the bottom, Amazon Web Services has built a highly reliable infrastructure using the same principles that powers Amazon.com retail website. Today, there are 5 regions around the world, 2 in the US, 1 in Europe, 1 in Singapore, and the newest one in Japan. Each region consists of multiple availability zones. Availability zones, or AZs, are logical data centers that don't share the same powering, cooling, flood panels, fault lines, and hence reduce the probability of failure and help you design better fault-tolerant websites. On the top of that highly reliable infrastructure, we offer a variety of different core infrastructure services. On the compute side, Amazon Elastic Compute Cloud, or Amazon EC2, is a web service that gives you access to virtualized instances on a pay-as-you-go fashion. You can spin up several EC2 instances within minutes and then get root-level access to each instance. You can take advantage of 1800 or so Amazon machine images that are available, or you can bundle your own operating system, your software with your configuration settings into your own Amazon machine image. All this can be done using simple web services calls or command line functions to scale elastically up and down. You can also purchase on-demand EC2 instances in which you pay for the instances by the hour, or take advantage of reserved instances in which you pay a low one-time payment and reserve the capacity as well as receive a lower usage rate than that of the on-demand instance. On the unstructured storage side, there are several options available. Amazon EBS, which is Elastic Block Store, stands for is essentially a network attached storage. It is a persistent block device that can be mounted onto an EC2 instance, and it is completely independent to the EC2 instance. You can provision what we call the volumes from 1 gigabyte to 1 terabyte and attach multiple volumes to an EC2 instance. Amazon S3, which is our simple storage service, is a highly distributed redundant data store. You give us a blob of data and the key to that data. We will take that blob of data and store it multiple redundant geographically distributed data centers. And you can retrieve that blob of data using the key that you have provided. All you have to worry about in S3 is get, put, update, delete, and buckets and objects. On the network side, Amazon VPC, or a virtual private cloud, offers network isolation, a true VLAN type functionality, so that you can securely connect your existing data center to the cloud and map the same IP address range that you have in your own corporate network and sort of get best of both the worlds. Amazon ELB is the Elastic Load Balancing service and allows you to create a load balancer so that you can route traffic among multiple EC2 instances. Amazon Route 53 on the network side again is our authoritative DNS service that allows you to programmatically manage DNS records. On the structured storage side, Amazon offers 2 alternatives today. Amazon SimpleDB is a highly distributed queryable key value store. A lot of people call this as a NoSQL option on Amazon. If you have relational data, you can use Amazon RDS or Relational Data Store, MySQL managed offering by Amazon that abstracts out and automates most of your database administration tasks so that you can focus more on your own application. The cool thing about RDS is with just few clicks, you can actually scale from a 2 CPU box to a 4 CPU box, as well as you can add more storage volumes. On the platform side of things, there are a variety of different options that serve a specific purpose. If you have lots and lots of logs and you like to process lots of these logs and process them parallelly across massively distributed EC2 instances, you can take advantage of Amazon Elastic MapReduce, which is a hosted Hadoop framework optimized to run on an on-demand infrastructure. There are several payment options available, like Amazon DevPay, which is a billing and metering platform. Amazon FPS is a flexible payment service that allows you to send payments and using the same Amazon.com user accounts. We have several edge locations around the world, and you can also take advantage of our content delivery network, Amazon CloudFront, that will edge cache your static content so that content is much more closer to the customer. Amazon Mechanical Turk is an on-demand workforce. It allows you to get access to lots and lots of humans to do a particular task for a short period of time. It's a really cool service that will help you design human intelligence tasks that are very difficult for computers to perform but very easy for humans to do. There are several services on the messaging and email side. Amazon SNS, it's our notification service, and it allows you to create a publisher-subscriber model where you create a topic and have subscribers subscribe to that particular topic, and then publishers will send messages, and all the subscribers can get messages very quickly and get notified. Amazon SQS is a highly distributed transient buffer and a kind of a workflow system. So it addresses the producer consumer pattern where you have several producers producing the jobs while putting messages inside the queue, while there are several consumers picking up those messages and creating a highly loosely coupled application. Like one of the newest services in this category is Amazon SES, or Simple Email Service. It allows you to send bulk email transaction using the same Amazon.com infrastructure itself. There are several cross-service features available that use lots of these underlying services. For example, Amazon Identity and Access Management is a simple way that allows you to create multiple users within a single account and assign them policies that restricts and allows access to individual AWS resources. If you like to monitor your cloud resources, for example Amazon EBS IO or EC2 instances CPU utilization, you can take advantage of Amazon CloudWatch, which is our monitoring service. One of my favorite services in this category is Elastic Beanstalk. Elastic Beanstalk makes it extremely easy to deploy and manage your applications. It essentially puts your application on an autopilot mode and creates and manages the underlying infrastructure so that you can focus more on the application and not worry about servers, instances, volume, load balancers. A lot of people like to call this as a platform as a service offering by Amazon. Likewise, AWS CloudFormation allows you to provision AWS resources with a simple JSON template. It's a provisioning engine. How you can access these services is very simple, and there are a variety of different ways available today. There are libraries and SDKs, which are simple single drop files that allow you to access programmatically all these web services using the APIs. Or you can have a point and click interface, our web interface, AWS Management Console, that allows several ways in which you can access these services. There are also tools and IDEs like the Eclipse Toolkit, which allows you to stay in Eclipse environment and also deploy directly from within Eclipse. And lastly, there are several command line interfaces that take advantage of these APIs, which integrate into your existing applications very quickly. So this is the complete buffet of what Amazon Web Services is offering today. There are three things common about all these services. Everything has an API, so you can programmatically access each one of them. You don't really have to use all the services. You can pick and choose the services from this buffet and make your own meal, your application. And thirdly, all these services inherently scale, either inherently scale or they give you an option to scale the application. So this is the living and the evolving AWS cloud. So we are continuously evolving as well as adding new services and expanding to new geographical regions. So stay tuned with our blog and our website to get the latest and the greatest of Amazon Web Services platform. So now let me tell you a story. This story is about scalability, about how you can start small and then gradually build a highly powerful, highly available, highly scalable, fault tolerant website in the AWS cloud using all the services that I just talked about in few moments ago. So once upon a time, not so very long ago, there was a boy named Andy. Andy was 25-year old, very tech savvy, and really keeps up to date with the latest and the greatest technologies. Like others in that age, Andy were also having a problem of finding dates. Every Thursday, Andy gets really frustrated about the fact that he has not secured a Friday night date. Necessity is the mother of invention. He knew how to code in PHP, so he started building his own website. He calls it Thursdate.com. Thursdate.com is not an ordinary dating website. It's a dating website in the cloud. It's a dating website that is having a really cool idea. It goes live on 4 p.m. Thursday and then shuts itself off 7 p.m. that the same day. It is only live 3 hours a week, and this gets repeated every Thursday of the week, thereby creating a Black Friday effect. Like lots of people are waiting for the clock to tick. As soon as 4 p.m. comes in, there are several people will log into the website, create their new profile, upload their videos, and then try to find a Friday night date. So it was an ephemeral website that truly leverages the on-demand cloud infrastructure. From the technical perspective, this was ideal for something to build on the cloud because you're only paying for the 3-hour time frame. At the same time, Andy knew that he has to scale so that it meets the customer demand during that 3 hours. So with its elastic capabilities, it will be ideal to build this website in the cloud. So is this idea a cool idea? Thursdate.com, it's magical elastic dating that happens every Thursday. So now let's see how Andy went about building this particular website. So Andy, he did a simple prototype, and this is how a Thursdate.com is going to look like. Most of the time, Thursdate.com is sleeping in quotes, and in a static website is being shown. But only for that 3-hour time frame, the website will go live and people will be able to log in and upload their profiles, their video, and then find each other at the date for the Friday night. He builds a simple web application. He starts an EC2 instance using the AWS Management Console, installs Apache, installs PHP module, configures it, and also installs MySQL in the single instance. He quickly runs certain scripts so that the MySQL binary logs are backed up to Amazon S3 every 2 hours. He creates an elastic IP. Elastic IPs are remappable static IP addresses. So it can point the domain name, that PHP website, in this case Thursdate.com, to point to this EC2 instance. With his minimal code and using open source technologies, he was able to launch this particular website very quickly in the cloud. He created the necessary security groups. he created the necessary configuration that's needed to quickly launch a website within 2 hours. So first pattern, he listens to several of the best practices that Amazon talks about all the time. The first pattern in designing web application is to design for failure and nothing will fail. With that design pattern in mind, Andy decided to make sure that his particular website that he has built, he has to quickly take advantage of some of the fault tolerant features that are available. So he makes sure that instead of just having an ephemeral instance, and in case it dies, he is to make sure that the data is not lost. So he creates Amazon EBS volumes. These are one root volume and one data volume, and attaches that volume to that EC2 instance. And then configures the EC2 instances so that every hour or so, periodically they get snapshotted onto Amazon S3. These snapshots are incremental in nature, so they actually for the subsequent snapshots so much. These are only the changed bits are going to be saved. So he also learned during this process that there are two ways in which you can create an Amazon machine image. One is S3 backed Amazon machine image, in which the Amazon machine image blob is actually stored in S3. And another one is an EBS backed Amazon machine image, which is also stored in S3, but in this case, it is first provisioned onto an EBS volume, and then EBS volume is bootable, so it will boot up to an EC2 instance. Certain more advantages of Amazon EBS backed Amazon machine image. So he tries to build that Amazon machine image because there are things like he can do stop, and it's also very fast to boot up. So with that in mind, he just builds this website and goes live. Few of his friends comes to know about his particular website, and he quickly understands that edge cache the static content. Now isolates the static data with the dynamic data. All the JavaScript, images, audio, video files are stored and are moved to Amazon S3. CloudFront distribution is created for that particular Amazon S3 bucket, and it exposes into a new CNAME media.thursdate.com. So all the traffic directly hits the S3 bucket, as well as the static content is edge cached, so it's more faster and it's more closer to the customer. By doing that, he also reduced the load on his EC2 instance, so this is another way to scale your web application. He also made certain cool changes and used some of the new features that Amazon S3 provides. For example, he used the post feature so that any client or any user actually when uploads a particular video of his own, he directly uploads to Amazon S3 versus going through EC2 instance and his web server. That way he's also distributing or isolating the traffic. So by creating and edge caching the static content, he created a slightly better design from what he had before. So he starts promoting his particular website. Few people log into this website. One of the colleges actually picked it up and they felt this was a really cool web application. Web application because every time when they log in, they get something new. There is no past memories. So always there is new content. So people log in and look out for the Thursday 4 p.m. So the first thing that he does is to scale that particular website. He moves that MySQL database to Amazon RDS Database, which is a separate DB instance. It's very easy to start a new RDS DB instance. He goes to the console, clicks through a few wizard screens, and then creates an DB instance. He uses MySQL standard import tools and moves existing database data into MySQL database in RDS. RDS automatically manages most of his database administration tasks, things like patch management, things like automatic backups, and so forth. He was able to save some of his time. So by moving the database out of his Amazon EC2 instance to RDS, he also created his EC2 instance slightly more lightweight. So there was another way to scale his current website. There was lots of cool side benefits of the dynamicity of the cloud. For example, he understood and learned that he can use some of these elastic IP addresses to his advantage when upgrading to new versions of his app. So for example, his first web application version and his source code 1.1, the Thursdate.com, has an elastic IP address that point to an EC2 instance that uses Amazon RDS. So when he wants to upgrade to newer version of the application, he simply starts a new Amazon EC2 instance. Let's call this staging EC2 instance. Puts the code, the newer version of his application, onto it, creates a new CNAME mapping. Let's call this staging.thursdate.com. Runs all his unit tests. As soon as the staging instance passed all the unit tests, he actually renames the staging instance as the production instance, and then connects the IP address to that of this new EC2 instance and simply terminates that old production instance. This was very cool from the past, from the things that he has done before, where we try to move code between these environments. Instead, he is just changing the staging instance to production instance. So there are some of these cool tactics and you're using dynamicity to your own advantage. So coming back to the original design, now he has simple website deployed using Amazon S3 for static storage, Amazon RDS for his relational data storage, Amazon CloudFront to actually edge cache the static content that's stored in Amazon S3, and also Amazon EC2 where the actual application is running. And he kept himself up to date with the latest and the greatest features of AWS. He was not only subscribed to AWS blog, but also was actively reading the AWS newsletter and talking to evangelists. So he knew that he had to be prepared just in case Thursdate.com becomes really successful. So he started doing his own research and understanding what he has to do next. So this comes to the third design pattern, to implement elasticity. Elasticity is the fundamental property of the cloud. So doing his research, he wanted to spike-proof Thursdate.com. So he decides to use some of the advanced features of Amazon EC2 to spike-proof Thursdate.com. The first thing that he does is creates an Amazon machine image of his currently running Amazon EC2 instance. Then he replaces the elastic IP to use the elastic load balancer, and then uses the auto scaling group. For creating the auto scaling group, he has to create what we call the launch configuration, specify the Amazon machine image that needs to be started, and specify the min and the max of the auto scaling configuration. His configuration settings were set such that if the EC2 instance CPU utilization goes 85 and above and it stays there for 3 minutes, automatically start a new EC2 instance from this particular Amazon machine image and tie that back to the load balancer so the new requests directly hit the new instances that come online in the auto scaling group. So by bundling an Amazon machine image, creating a launch configuration, and also creating the elastic load balancer, he created a highly scalable web application. He also realized that because everything is happening in the cloud, there is this need of getting notified. So he took advantage of the Amazon simple notification service and configured such that in case the EC2 instance terminates or dies, then it will automatically notify him via email. He also moved some of the catalog data and configuration data to Amazon SimpleDB and started to monitor the Amazon RDS, EBS Volumes, as well as EC2 instances using Amazon CloudWatch on his iPad. So there are two benefits of using the auto-scaling service. The first is resiliency and self-healing. You can set the minimum threshold of the number of EC2 instances you would want to always run. So in case all the EC2 instance dies, it'll automatically start the new EC2 instance. And the second, it will allow him to horizontally scale his web tier from one EC2 instance to multiple EC2 instances, thereby creating a highly scalable, highly resilient web application. So all the components of this web application are now inherently scalable. Either they are scalable by design or they are configured to scale, except one, which is the relational database. And this is very typical in the designing web applications, that relational database are usually the bottleneck. So Andy starts to research more about the database and what are the database scaling options available with Amazon RDS. This comes to our fourth pattern, leveraging multiple availability zones in order to create a highly available database. One of the cool features of Amazon RDS is a multi-AZ. With just a click in the management console, you can create a standby slave in another availability zone, which will do synchronous replication from the primary to the standby, and also monitor through health checks that if the primary fails, it will automatically fail over to the standby, thereby creating a highly available database. So after implementing the multi-AZ feature, he starts to look at his read and write traffic to the relational database. And this brings us to our fifth pattern, isolating your read traffic with the write traffic, just like we isolated the static traffic from the dynamic traffic by using CloudFront. He quickly realizes that there is this new feature of Amazon RDS called read replicas. With just few clicks on the management console, he can create multiple read replicas in the same availability zone, which will do asynchronous replication from the master to the slaves, and all the read traffic will be automatically going from the read replicas, while the write traffic will keep on going through the master. So by isolating the read traffic by the write traffic, he is making sure that the master is not overloaded, and the read replicas continues to serve the read traffic, and thereby creating a highly scalable design as well. So now Andy has created a two-tier, highly scalable, highly durable, fault-tolerant website. His traffic is increasing every Thursday. From now hundreds of people, he has moved to thousands of people, and he starts implementing new features. The beauty about Thursdate.com is that there are no past memories. Everything when you log in is going to be new. There are going to be new people and there are going to be new profiles. So whatever happens in those 3 hours, it stays in that 3 hours. So he starts implementing new features like themes. You can be a doctor one day, or you can be a geek one day, or you can be a philosopher one day, and so forth. This picked up the traffic even further. So now he gets several thousands of people logging in to Thursdate.com at 4 p.m. every Thursday and to find and secure that date. So in order to implement these features, he started to invest some time in automating the software development lifecycle. And this brings us to the pattern number 6, which is automating your in-the-cloud software development lifecycle. In a typical software development lifecycle, there are 4 stages: dev, test, QA, staging, and production. And each one has its own requirements. For example, dev might be all the components in one instance. Test and QA, you might have two-tier application with a small database, the dummy data. Staging will be having production data and having a little bit more highly scalable application, while production environment might be a highly available and a multi-AZ environment. And he decides to use AWS CloudFormation along with Chef and Puppet, which are configuration management tools. AWS CloudFormation allows him to create individual environments using simple JSON templates, and this gives him the ultimate flexibility to not only tweak the current environment but also put that JSON template and in a source code repository so that he can make some of those changes and then roll back if something goes wrong. As more and more people started to use the system, more and more complaints started to come in that the website is not performant enough, it's not fast enough, it's not responsive. So that brings us to our seventh pattern: cache as much as possible in your web application. So he started to re-architect his web application from a two-tier design to a three-tier design with a complete caching layer. He decides to use Memcache. You can run multiple instances of Memcache on a single EC2 instance, thereby creating a highly performant web application. All the requests now go to the cache tier rather than going to the database. And if the data is already existing, it will quickly revert back and give the results back to the application server. So by moving from a two-tier web application to a three-tier web application, he is creating not only a highly scalable web application design, but also a highly performant one. Security is often a concern expressed by those who are building applications in the cloud. So that brings us to our eighth pattern: hardening security at every single stage. With cloud, it's very important to understand that security is a shared responsibility. And Andy also did his research to go to our security center and understanding how to implement security in his application. To understand the shared security model, it's important to understand that there is infrastructure security, the things that we do to make sure that our infrastructure is secure. Most of this is validated by the certifications like SAS 70 Type 2 audit, ISO 27011. Amazon is PCI DSS level 1 compliant, as well as now you can run HIPAA and SOX compliant applications on AWS. Like infrastructure security, there are several services and features available like identity and access management, multi-factor authentication, VPC, using encryption and encrypted file systems in EC2, using security groups features, and so forth. And lastly, it's also the responsibility of the developer, so that you can use some of the traditional best practices that you have used in the past also in the cloud, and make sure that you're patching your operating system, you're writing better secure applications, and avoiding SQL injection and cross-site scripting errors and so forth, and encrypting data in transit, encrypting data in rest, and so forth. So by together understanding this particular model, you can build highly secure application. So coming back to our Thursdate.com example, Andy did implement security groups in a very unique way. Now, web servers only talk to the application servers, and application servers only talk to the caching servers, and caching servers only talk to the database servers, and having separate security groups and denying all other access. For example, the load balancer is only exposed to port number 80 and 443, while all other access is denied, while the database, the only port that is open is 3209 in this particular case, and all other ports are closed. So by having and using some of the security features, implementing it in the right best practices way, you can make sure that your application is highly secure. So now with a secure web design and a highly performant and highly scalable design, Andy is able to get people to work for him, and with teamwork, he's able to increase the traffic to his website from tens of thousands of people to hundreds of thousands of people accessing his particular website. In order to meet that growing demand, of hundreds of thousands of people accessing Thursdate.com concurrently, he has to make sure that the website never goes down. And in order to do that, Andy takes it to the next level by taking advantage of availability zones. Because he has already built the Amazon machine images, elastic load balancers also work across log availability zone. With just few clicks, he's able to actually instantiate that entire infrastructure in another availability zone and quickly increase the availability SLA of his website. Now, Andy has tasted success and he doesn't want to stop, so he is on a mission to go global. He wants to offer Thursdate.com to all parts of the world, including Europe and Asia. And this brings us to our ninth pattern. The cloud allows you to go global very quickly with a single API. However, there is a problem. If the application is deployed in US East region and the users are accessing from, let's say, Asia Pacific, due to geographic distance, there is going to be latency. So what if from a centralized architecture like this, we can go to a geo-distributed architecture where we deploy Thursdate.com in every region around the world so that users from Asia Pacific only access the application deployed in Asia Pacific. And if we want to do data replication between all the regions, we can use some sort of a open source data replicator. Because Amazon Web Services offers 5 regions around the world, and because all of them have similar identical services and all of them use similar APIs, it's very easy to go global. As you know, Andy is a really smart dude, and whatever he does it with style. So he wanted to understand what is the best way to go global while keeping your costs down that truly leverages the cloud infrastructure. So he goes and builds something what I call the follow the sun model. Follow the Sun truly leverages the auto scaling and the elasticity of the cloud platform, such that the application automatically scales during the daytime when the users are actually accessing the system, and then scales back down when during the night time, technically sleeps during the night time when the users are not accessing the system, when you don't need the application to be up. It uses GeoIP directional DNS to route the request to the nearest server, and it uses master replication using software-based data replicator in case you need data in all regions. There are going to be geographic latency in that, but you can truly leverage the on-demand auto scaling as well as elasticity of the AWS infrastructure by building this follow the sun model. Now this is only possible when you have consistent set of services and consistent set of APIs available in different regions around the world. Now how cool is that? So now this follow the sun model worked well for Thursdate.com, but that does not necessarily mean that it will work for all the application use cases and all the architectures itself. There are different ways in which you can implement the follow the sun model to increase efficiency of your application overall. The first model obviously is on the database side, that you can implement software-based data replicator which will trigger based on every insert and update happening and replicate the data across multiple regions. The second design is to have a single master where all the writes will happen, and then have slaves in each region which will be replicated through asynchronous replication. And the third design is to have MySQL master replication across all regions. Ideally, these are just the different architectural database architecture design patterns that you might be able to take advantage on your use case. Now, Andy is a celebrity. He knows that he can build a highly scalable web application that can go global. But the beauty about the cloud is the fact that you can keep on optimizing. And that brings us to our final pattern, that keep optimizing your infrastructure and you will see the savings in your next month's bill. So an example is now investing in reserved instances. Investing in reserved instances not only ensures you that you have the necessary capacity when you need it, but also overall in a 1 year, 3 year time frame, your overall cost reduces from up to 40%. So you are not only saving on your infrastructure, but also by changing part of your infrastructure and adding more optimizations, you can actually make a significant impact in your next month's bill. So in conclusion, we were able to see how Andy started small and was able to build a powerful web application which is highly scalable, highly available, highly responsive, fault tolerant, cost effective, and that is globally deployed around various parts of the world using all the different services that Amazon Web Services offers today. For those of you who are still wondering what happened to Andy and his love life, Andy did find a beautiful young girl and they are madly in love with each other and they are happily married. And everybody knows the first love for Andy is still the clouds. So I hope you enjoyed this presentation. If you really like the presentation, please do get back to me. My email address is jvaria@amazon.com. And before you ask, yes, these slides are available on slideshare.net/Amazon Web Services. Please get back to me if you have any questions. Thank you very much for listening. And if you like this particular presentation, you will like other white papers that I have authored. You can find them at aws.amazon.com/whitepapers. Again, thank you very much for listening.